In the name of Allah, who is most beneficent and merciful. My name is Sumaya Viva. I'm from Chemistry Department. My ID is 014. And today I'm here to present a practical. The topic of my practical is to determine amount of aluminium by back complexometric titration method. So let's start with the aims of this practical. First one is to determine the quantity of aluminium present in a sample using back titration. The second one is to know how aluminium form complexes with ligands. The third one is to determine the concentration of an unknown sample. Here you can see a principle of this practical. Complexometric back titration generally performs when the metallic ions form a stable complex with EDTA in a slow reaction, or when a metal ion blocks an indicator. The blocked indicator cannot release metallic ions, thus no color change will be observable at the endpoint of complexometric direct titration. Both conditions exist in the case of the aluminium ion. Thus, the ion is the best determined by complexometric back titration along with heating to enhance the complexation of aluminium EDTA. In this analysis, an excess known amount of EDTA is added to the aluminium sample solution, followed by a pH 10 buffer solutions where the aluminium EDTA complex can form. To prevent aluminium ion blocking the indicator and to facilitate the aluminium EDTA complexation, heating the mixture prior to adding the indicator ferrochrome black tea, wherein its free form is a blue color. The amount of unchelated EDTA can be then determined using complexometric back titration with standardized zinc or magnesium solution. At the end point, a change to wine red color is observable. And the change, which is observable at the end point, is because of the formation of zinc or magnesium chrome black tea complex. Now here you can see two equations. First one shows that when analyte reacts with excess amount of EDTA, then metal ion EDTA complex is formed, and there is also unreacted EDTA. Now in the second equation, you can see reactants are unreacted EDTA, free indicator, and titrant, and products which are formed in result of this equation include metal ion EDTA complex, metal ion indicator complex, and hydrogen ion, which is H positive. Here we can see reagents which are used in this practical. Aluminium ion solution as analyte, chrome black tea as indicator, standardized 0.01 molar zinc sulfate solution as a titrant, and 0.01 molar EDTA solution. Now here you can see procedure of this practical. Pipette 25.0 ml of aluminium ion solution into 250.0 ml and add an excess known amount of 0.01 molar EDTA solution and add sufficiently buffer solution pH 10 just to make the solution ammoniacal. Boil the mixture for a few minutes to ensure complete complexation of aluminium. Then cool to room temperature and adjust the pH to 10. Add 50 mg of chrome black tea indicator and titrate rapidly with standard 0.01 molar zinc sulfate solution until the color changes from blue to wine red, and then record the used volume. Repeat this titration twice. Now here you can see precautions. It was ensured that the purity reading was taken from the bottom of the meniscus. The pH range at which the complex would form was determined and the solution adjusted and kept at that range. The buffer solution was heated to increase the buffer formation and the complex formation. This was to ensure that the entire aluminium has been complexed and only excess EDTA existed in solution. At last, you can see calculations of this practical. There are two equations. First equation shows for the calculation of the concentration of aluminium ion solution in mole per liter, and the second one is for determination of concentration of aluminium ion solution in gram per liter. So this is the practical for the determination of the amount of aluminium ions, which we determined by bare complexometric titration. So it was all from my side. Thank you.